So it says a manufacturer of a processing chip knows that 2% of, I love that it says 2% of its chips are defective in some way. Suppose an inspector randomly selects 4 chips in for an inspection. Assuming the chips are independent, what is the probability that at least one of the selected chips is defective? Let's break this problem down up into smaller pieces to understand the strategy behind solving it. So you're going to find the probability that a randomly selected chip is not defective. So first of all, the probability of it being defective is 0.02. So what's the probability of it not being defective? 0.98, okay? And the way we got that is by going 1 minus 0.02, okay? So now find the probability that all 4 chips are not defective, okay? So find the probability that all 4 chips are not defective. So the way that I kind of imagine this, you remember how we did that tree diagram the other day? So I'm going to take chip 1, and either it's defective or it's not, right? So it's either 0.98 or it's 0.02. Now chip 2 is either 0.98 or it's not. Chip 3 is either 0.98 or it's not. And this will make sense in a second. And then chip 4 is either 0.98 or it's not. That's a little messy. Chip 4 is either 0.98 or not. And you're going to do the same thing for down here. Chip 2, chip 3. It's so messy because there's so many branches. Chip 4. And I'll show it to you in just 1 second. There's 1 strand that we need, and then that's it. I need more space on my paper. Yes. What's going to happen is the chips that are not defective. So we're looking for 1 strand. So really, I shouldn't have had to draw all this out, but we're looking at this strand because the first chip is not defective. The second chip is not defective. The third chip is not defective. The 4th chip is not defective. Yeah, do we see it? Okay, so what you're going to do in order to figure out that probability, you're going to take 0.98 and you're going to multiply it by itself 4 times. Okay, so you're going to go into your handy dandy calculator and you're going to go 0.98 4 times, which is going to give you 0.9223. Okay, so the probability of all 4 not defective is 0.9223. Okay, so now we're going to find the probability that at least one of the selected chips is defective. Okay, so what we're going to do is we're going to take 1 minus 0.9223. Again, go into our handy dandy calculator and we're going to subtract. And that's going to give us 0.0777. So 0.0777. Yeah. So it's about 7% that we're going to get a chip, at least one. Okay. So on the next one, go ahead and take a moment and kind of follow that same process, and we're going to go over it in just 1 second. All right, so it says surgical implants. Surgeries involving implants sometimes result in the patient's body rejecting the implant. Right? A certain surgery has a rejection rate of 11%. The rest of the patients successfully accept the implant. Okay, so assume the results of each patient are independent. In a random sample of 8 of these surgeries, find the probability that at least one patient rejects the implant. Round your answer to 3 decimal places. Okay, so first of all, we've got this 11%, which is the rejection rate, right? So the probability of the rejection is at 0.11. Let's first find the probability that they're not going to reject it, right? Good. So we're going to subtract 1 minus 0.11. What is that going to give us? 0.89, okay? So then they have 8 surgeries. So we're going to take this 0.89 and we're going to raise it to the 8th power, or we're going to multiply 0.89 by itself 8 times, okay? So we're going to go into our calculator, we're going to say 0.89, and we're going to raise it to the 8th power, and that's going to give us 0.39, and it said round to 3 decimal places, 4. So you've got a 39.4% of at least one being rejected out of 8 surgeries. That's pretty high. Like that's not good. Esther is a basketball player who makes 75% of her free throws that she attempts. Assume that the results of each shot are independent. If Esther attempts 3 free throws, trying to say 3 free throws 10 times fast is hard. Find the probability that she misses at least 1 free throw. Round your answer to the 3 decimal places. So first, we've got the probability of her making a shot, right? Which is that 0.75. Okay. And so this one's worded a little differently. Okay. This is kind of opposite of what the other one was saying. So we're wanting to know that she misses at least 1, right? Okay. So first we're going to try to find the probability that she makes all of them, right? Which they've already told us that. Yeah. Okay. So they told us how many she's going to make. And then we want to say, all right, for 3 free throws, what's that probability? That she makes 3, right? So we're going to say 0.75. Say it again. Yep, 0.75 to the 3rd power. And so that's going to be, you said it. What is it? 0.42. 0.4219. And now we want that she at least 1 miss. So that's going to be 1 minus that 0.4219. So when we do that, that's going to be 0.578. Okay, so this one's worded a little differently because they tell us how many she makes, right? So key topic is going to be probability problems. Okay. And this is going to help us by selecting the right strategy formulas in order to solve. Okay. Because if you use the or, so you add instead of multiplying, that's going to give you a really different probability, right? So we've got or problems, and then we've got and problems. And there's a couple of different details that you want to include in this and deciding whether or not it's a or an and problem. So with and problems, you're going to ask yourself, are the events independent? And if they are, then the probability of A and B is probability of A times the probability of B. So if they are independent, then you're going to multiply them. if they are dependent, then the probability of A and B is going to be probability of A times probability of B given A. Notice how there's just a little slight difference between those two formulas. They're still multiplying, but you're taking the fact that A depends on B, right? Or B depends on A in this instance. So one important thing to note is that if A and B, A and B are independent, then probability of B given A is the probability of B. So with OR, you're going to ask yourself, are the events disjoint? Which is a fancy way of saying mutually exclusive. If they are, then the probability of A or B is the probability of A plus the probability of B. If they're not, then the probability of A or the probability of B is equal to the probability of A plus the probability of B minus their intersection. Okay, so this is the one where we're going to take both probabilities, add them together, and then subtract the one that they cross over at. Okay, and one thing to note is that if A and B are disjoint, then the probability of A and B, the probability of A and B is going to equal 0.